morning everyone. Welcome to the Mercury Virtual. Hope you are doing good. Today I'm going to continue with your series that is the program when we do the programming in the Java. In the last class we are finished with the, that is in the Friday's class, we are finished with the chapter number 27, Java collections. Java data structures. That means that chapter includes what are the various data structures that is available in the Java for making the Java comfortable, for making Java efficient to use, and how to deal with programming in the Java. Now let's move to the next chapter, that is chapter number 28, Java collections. So prior to the Java 20 or 2 version, Java provides different classes such as directory, vector, stack, and the property to stack the variables or to store the variables and manipulate the group of the objects. That is what are the various variables that is used to develop the objects, to develop the matrix that is available with the group of the objects. Although these classes were quite useful, then they lack a central unifying theme. So there are multiple themes that is available for unifying the or getting a data themes. Therefore, so shall we start the session right now? Now it's okay. Okay. So we are studying about the Java collections. So what are the various classes that is including in the Java? What are the various classes that is used to store and manipulate the group of the objects? And some of the classes are the directory, vector, stack, property that are used to store and manipulate the group of the object. Although these classes were quite useful, but there are limitations of these classes. Now, what are the various limitations of these classes? They are not using, or they lack the central unidentified scheme and unified scheme. Therefore, the way you use the vector have different properties, have different challenges that is stored by that challenges will be faced by the Java collections. The collection framework were designed to perform operations to meet the different goals. What are the various goals? The framework has to be or had to be high performance. So there are high performance of the data, high performance of the resources that is used for the Java collections, and the implementations for the fundamental collections. That may be a dynamic array, that may be a linked list, that may be a tree, that may be a sorting, that may be a searching, that may be a hash table. That are the fundamental collections that are highly efficient in the framework, that are highly efficient in the fundamental looping, that is known as the framework for the high performance. And the framework has to allow different types of collection to work in a similar manner with a high degree of the interoperability. So the framework has also collection or also allow the different types of collection, that is a collection of the or the working material that is to work in a similar manner with a high degree of the interoperability. Then extending or adopting a collection that has to be easy. That means we are focusing on this chapter. We are focusing in this chapter that is how to use and adapt a collection that is very easy to perform the data, that is very easy to maintain the data. So first one is framework has to be or had to be highly performance or high performance. Then framework had to allow different types of collections. Then extending or adapting a collection that is also easy method. Towards this end, the entire collection framework is designed around a set of the standard interfaces, and these standard implementations are also followed using a linked list, hash set, tube set, or tree set of these interfaces that are provided that you can use as is, and you may also implement a collection that is your own collection if you choose. So a collection framework is a unified architecture for representing and manipulating the collection. So whenever we use frameworks, it is nothing but the architecture for representing and manipulating the collection. So framework is like a block, like a looping, whereby we are using or whereby we are representing the collections, we are representing the classes for the collections, and also manipulating the collections. And the framework also contains features. What are the various features that is contained by the collections? The first one is the interfaces. So these are the abstract data types that represent the collection. Abstract data type means these are the data types that represent the collection that is also the interfaces. And interfaces also allow the collection . interface means the abstract data type, that means a hidden data type that may be int, float, and any data type that represents the collection, that is the interfaces, and also or it also allows the collection to be manipulated independently. So the collections or the manipulation is done on an independent basis. And in object-oriented languages, interfaces also generally form a hierarchy. So there is a hierarchy that is formed by the interfaces. The next one is implementation, that is the classes. That is how to implement in the classes or how to implement in the collection of the framework, that is known as the classes. So these are the concrete implementations of the collection interface. That means whenever we use the collection interface, whenever we are saying that there is a collection, there is a proper study of the collection interfaces that are known as, or these are the concrete implementations of the collection interfaces. And in this regard, they are reusable data structure. Reusable data structure means they are reused data structure for the classes. The next one is algorithm. So these are the methods that perform the useful computations such as sorting, searching on an object that implements the collection interface. So whenever we are using the interface, whenever we are implementing the interface, so how we can implement or how we can search, sort for the things, for the objects that implements the interfaces. The searching sorting is known as or is done by the algorithm. So these are the methods that perform the useful computations such as searching, sorting on the objects that implement the collection interfaces. So first one is the interfaces, that is a unified structure for representing and manipulating the collections. Then there is the implementation, then there is the algorithm. So one is the interfaces, then there is the implementation, that is the classes, then next one is algorithm. And in addition to the collections, the framework also defines several map interfaces in the classes. And maps also stores the key values pairs, and the maps are not the collection in the proper use of the term, but they are fully integrated with the collection. That means they are fully integrated with the collection with the terms that is defined in the interfaces with the classes. So in simple terms, when we combine the classes, so that means when we combine the data members as well as the member functions into the one unit, that is known as the classes. So that is also part of the collection, that is also implementation of the collection. So collection means the things. So in the classes there is a working of as well as the member function. That implementation is done, that implementation is followed by the order by the classes. What is the collection interfaces? So what are the various interfaces by which we can use the collections? So the collection framework defines multiple interfaces. So what are the various interfaces? That is used in the collection interface. Collection framework provides or defines the multiple interfaces. Now, this is a table that shows what are the various interfaces along with the description. First one is the collection interface. This enables you to work with the group of the objects that is at the top of the collections hierarchy. So whatever the collection hierarchy, that means whatever the data that is available at the hierarchy level first, that is used to combine, that is used to work with the group of the objects that is available at the hierarchy. Next one is a list interface. So one is a collection interface, that means a combination interface. So how to combine with the data or how to combine the multiple data together, that is known as a collection interface. Then list interface, so this extracts a collection and an instance of the list stores an unordered collection of the elements. So how to make the data collection possible with the data collection, with the extending of the collections, and how to use a list that is stored with the ordered collection of the or ordered usage of the collections. Then the set, so this extends the collection to handle the sets. So whenever we are combining, whenever we are using the collection of the sets, that must contain the unique element. So collection must contain the unique element for the set purpose to handle the set. That means how to maintain the group, what are the various unique elements that is maintaining the groupism. So one is a collection interface, the next one is a list interface, the next one is a set, the next one is a sorted set. That means this extends the set to handle the sorted set. So whenever we are using the set, that means a group, and whenever we are using the sorted set, that means either arranged in ascending order, descending order, alphabetically, whatever the terms that is used, so that is the sorted order or the sorted set. This is the extended version of the set or the set class. Then next one is the map. So this map unique keys to the value. So whatever the unique keys that is available, so this maps the content to the value. This maps the features or the keys to the values. Then the map entry. So this describes an element in a map. Describes the element means that is available in the map, that is describes what are the various key parts, what are the key pairs in the map, and this is the inner class of the map that is available or that is stored in the map entry. Next one is sorted map. So one is a map entry, that means how to enter the data or what are the various key values of the pairs that is available in the map, and this is the inner or this is an inner class of the map. The next one is the sorted map. So this extends the map so that the keys are maintained in extended or ascending order. So whenever keys are maintained in ascending order, that ascending order will be represented in the sorted map. So this extends the map so that the keys are maintained in ascending order or the descending order, that means the sorted map. The next one is enumeration. So this is the legacy interface and defines a method by which you can manipulate, that is obtained one at a time, and whenever we are representing the collection in the interface, that is that representation will be done in the legacy system, and representation will be done in a collection of the object, and that is known as the enumeration. And this legacy interface has been superseded by the iterator. So there is an iterator that is used for the superseded, that is used for the enumeration. The first one is the collection interface, the next one is the list interface, then the set, then sorted set, then map entry, sorted map, then enumeration. So these are the 8 points for the interfaces that is used in the mapping. Now this is the collection interface, how to use the interface or what are the various interfaces that is defined in the collection. Next one is what are the various classes that is defined in the collection. So my task is first of all read out this one, because these 8 are the base for the next one, that is the collection classes. So read out these 8 collection interfaces for 5 minutes. So next one is the collection classes. So how to use the collection classes. So any doubts in the collection interfaces? Any doubts anyone in the collection interface, list interface, set, sorted set, map entry, sorted map, and the enumerations? Any doubts anyone? So let's move to the next one, that is the collection classes. So Java provides a set of the standard collection classes that that implements the collection interfaces. As I said, that the collection interfaces are the base for the collection classes. So whenever we are using the classes or collection classes, that means they are able to, or they are used to maintain, or they are used to implement the collection interfaces. Some of the classes that provide full implementation that can be used as is and others are abstract classes. That means they are used as abstract classes, they are used as combined classes implementation, and others are the abstract classes that providing the skeleton implementation that are used as a starting points for creating concrete collections. So we are maintaining the concrete collections, we are maintaining the skeleton or the skeletal implementation that are used as a starting points for creating the concrete collections. So that is known as a collection classes. So we provide a set of the standard collection classes that implement the collection interfaces. So in Crux, whenever we are using the collection classes, that means they are used to implement the collection interfaces. Now, what are the various classes that provide the full implementation? They are used as a starting point for creating the concrete collections. Standard collection classes are summarized in the following table. So this is a table that shows how to maintain the standard collection classes. So first one is the abstract collection that implements most of the collection interface. So whenever we are implementing most of the collection interface, that is known as abstract collection. The next one is abstract list, which extends the abstraction collection and implements most of the list interface. So whenever we are implementing the list interface that is obtained in the abstract manner, that is known as the abstract list. So this extends the abstract collection and implements most of the list interfaces. So these are the two that is very important. One is the abstract collection, one is abstract collection, one is abstract list. Then next one is abstract sequential list. One is abstract collection, then list. The next one is the abstract collection list, that is a sequential list that is used for maintaining the abstract classes. So any doubts anyone in the abstract collection, abstract list, and the abstract sequential list? Any doubts anyone? So first one is abstract collection that implements most of the collection interfaces. That is how to make the interface clear. The next one is abstract list. This extends the abstract classes and implement most of the list interface. That means this is related to this one. The next one is abstract sequential list. So this extends the abstract list for use by a collection that uses a sequential rather than the random access of its implementation. The next one is a linked list. So this implements a linked list by extending the abstract sequential list. So whenever we are extending the abstract sequential list, that is representing the linked list by implementation of the abstract sequential list. So first one is related to the second one. Now third one is related to the second one, and this fourth one, this implements a linked list by extending the abstract sequential list. That means this is extending this third one. The next one is the array list. That is the collection of the arrays. But whenever we are combining the multiple element, that is known as a dynamic array. This implements a dynamic array by extending the abstract list. Then abstract set. This extends the abstract collection and implements most of the set interface. Whenever we are using the set interface, whenever we are combining the set interface, that is done by the abstract collection. The next one is the hash set. Now, abstract set and the hash set are related with each other. So when we combine multiple together, that is the way how we are using the abstract list. So we extend the abstract set for use with the hash table. So whenever we are using the hash table, so that is extending with the hash set. Then the linked hash set. So this extends the hash set to allow the insertion order in iterations. Then tree set. So this implements a set stored in a tree. So whenever we are implementing the set that is stored in the tree, that is known as a tree set, and this also extends the abstract set. So whenever we are extending the abstract set that is defined with the tree set, so this is the abstract set. This is the 6 point, and this is extendable by these 7, 8, 9 points. So whatever the point that is written in the board, that is abstract collection, this is one of the base class. Then one of the abstract list, and again one of the base class, and abstract sequential list, again one of the base class. Then these available in the red ink, that is the base, or that is defined on these 3 base classes, that is abstract collection, then abstract list, then abstract sequential list. The next one is abstract set. This is also one of the base class, and this is also followed by the 2 classes, sorry, 3 classes. One is a hash set, one is a linked hash set, one is a tree set. Now, next one, 10th one is the abstract map. So this implements most of the map interfaces. So whenever we are using the map interface, that is abstracted or that is done by the abstract map. So on this, there is a class that is known as a hash map. This extends the abstract map to the user hash table. That is a hash map. Then there is a tree map. So this extends the abstract map to user tree. So one is a hash map that is using the abstract map for the hash table, for defining the hash table. One is a tree map for extending for using a tree, we are using the tree map. Then weak hash map. So this extends the abstract map to use a hash table with the weak keys. This is a base class over which there are the 5 functions or the 5 classes that is defined. One is a weak hash map, so it's an abstract map to use the hash table with the weak keys. Then link, use the insertion order iterations, use the linked list. Then identity hash map that extends the abstract map and uses the reference equality when comparing the document. That is how to use equality operators when using with the document, when using with the quality reference material. And as I told you that whatever given in the dark, whatever given in the board, these classes provide the skeleton implementation of the core collection interface. So that means these are used as a base for the other classes to minimize the effort that is required to implement them. And the following legacy classes is defined by the java.util. So there's a java.util that has been discussed in the chapter of this chapter for the java.utility program. So these are the 15 classes that is used as a base for provide the skeleton implementation. In the same way, these are the classes that are defined by the java.util. That is also one of the classes that is used in the hash table, that is used in the weak table, that means collection classes. So first one is a vector. So this implements a dynamic array. So wherever we are implementing the dynamic array, that implementation will be done, that dynamic array implementation. Now, what is the main difference between the static implementation and the dynamic implementation? And anyone, can you tell me the answer of what is the difference between the static array and dynamic array? Okay. No, I want the exact difference between the static and the dynamic. I don't want the definition among these. I want the exact difference. Okay, just think of it. Wait for 2 minutes. This is clear to each and everyone. Now, tell me the difference between the static array and the dynamic array. Yeah, this is the right answer. Static array means that is available at the compile time and that is available at the runtime, that is known as a dynamic array. That means whenever there is a flexibility, that is known as a dynamic array. Whenever there is no flexibility, everything is constant, everything remains same, that is known as the static array. This is the main difference between the static array and the dynamic array. Now, first class that is used, also known as a vector, this implements a dynamic array. That means it implements a runtime array, and it is similar to the array list, but there are some differences in the dynamic array and the vector list and the array list. Next one is the stack. So a stack is a subclass of a vector. So whenever we are using the subclass of the vector, that implements a standard last in first out stack. There is a LIFO methods, that is the last in first out stack, that is known as the subclass, or that is known as the subclass of the vector that implements a standard stack that is based on the LIFO. We have studied about the LIFO in the last class, that is last in first out. That is the last operation, that is key in, that is input into the stack, that is first out, or the first element that is phased out. So last element, that means the last operation that is performed, or last element that is inserting in the stack, that is the first element that is to be pop up, that is known as the LIFO. Next one is dictionary, that is the abstract class. That means whenever we are hiding the details of the class, whenever we are hiding the methods, that is known as a dictionary, and this is the abstract class that represents a key value storage repository and operates much like the map. So whenever we are using the repository, whenever we are operating like a map, this is known as the dictionary. The next one is hash table. So that was also a part of the original Java.util, and it is a concrete implementation of a dictionary. So whenever you're using a concrete implementation of a dictionary, that's known as the hash table. Next one is the property. So these 4 points, one is the vector class, one is the stack class, one is the dictionary class, one is the hash table. Next one is the properties, that is also a subclass of the hash table. It is used to maintain the list of the values, or we can say list of the methods in which the key is a string and the value is also a string. So there are 2 types in the key, in the values. One is a key, that is a string. One is a value, that is also a string. Key is also the string data type. Value is also of the string data type. The next one is the bit set. So a bit set class creates a special type of array that holds bit values. Bit set means a group of the bits, that means that contains collection of the array, or these are the special type of the arrays that hold the bits value. And this array can increase in size as needed. So whenever we are using the size, whenever we are need the new size, that is done by the bit value, that is done by the bit size. So first one is a vector, the next one is a stack, the next one is a dictionary, next one is a hash table, next one is the properties, next one is a bit set. So these are the few classes that is explained in the legacy classes, or that is available in the java.util for managing the collection classes. We can say for operating on the collection classes. So these are the few classes that is available in the java.util. A vector, stack, dictionary, hash table, properties, and the bits. So we are finished with the collection classes. We are finished with the collection interfaces. Right. So interfaces is over, classes is over. Now next part is algorithms. This is one of the, we can say, best part of the data structure. That is how to maintain the algorithms, or how to use the algorithms. The collection framework defines multiple algorithms that can be applied to the collections and maps. So whenever we are applying the collections and the map to the algorithms, that is known as the collection algorithm. So collection framework defines several algorithms that can be applied to collections and maps, and these algorithms are defined as static methods with the collection classes. Static method means method that remains the constant. So these are defined as setting methods within the collection class. So algorithms, what is algorithm? That is a step-by-step sequence of how the program will run. So the collection framework defines multiple algorithms or several algorithms that can be applied to the collection and the maps. Now, what are the various methods that is defined in the collections algorithm, or what are the various classes that is defined, or what are the various functions that is defined in the collection algorithms? So most of the methods that can throw a class cast exception that occurs when an attempt is made to compare the incompatible types, or unsupported operation exception, which occurs when an attempt is made to modify an unmodifiable collection. So whenever there is an attempt to compare the incompatible types, or whenever there is a method to compare the collection type or modify unmodifiable collection, that is done by the supported or the class cast exception. So this occurs when an attempt is made to compare the incompatible types or the unsupported operation exception. Now the collections define three static variables. One is an empty set, one is an empty list, and one is an empty map. So these are the three classes, or these are the three static variables that is defined in the collection algorithms. First one is known as the empty set, next one is known as the empty list, next one is known as the empty map. And all these are the immutable. Immutable means all these are used as static functions, that is the immutable. So collection defines three static functions or three static variable: empty set, empty list, and the empty map. There is only one algorithm, or we can say there is only one method that is used with the collections, that is known as the collection algorithms. Now, we are finished with the collection algorithms, we are finished with the collection interfaces, we are finished with the collection classes. Next is the same implementation, how to use an iterator, or how to use the iteration, that is a looping in the Java. So often you will want to cycle through the elements in the collection. So often means usually, generally, you will want a cycle through the elements in a collection. For example, you might want to display each element. So whenever we are displaying the each and every element, that is known as an iteration. So the easiest way to do this is to employ an iterator, which is an object that implements either the iterator or the list iterator interface. So whenever we are implementing the iterator, whenever we are implementing the list iterator interface, that is known as the iteration, or that is known as the looping. So easiest ways to do this is to employ an iterator. Employ means use an iterator, which is an object that implements either the iterator or the list iterator interface. And iterator also enables you to cycle through a collection, obtaining or removing the elements. So whenever we are using the iterator, whenever we are combining the elements, whenever we are maintaining the elements collection, that is defined with the iterators. And list iterator extends the iterator to allow bidirectional transversal. So whenever there is a or directional traversals of a list and the modifications of the element, that is known as the iteration, that is known as the iterator function. Now next one is what is the iteration methods, or what iteration method is used in the Java with the description. So using the Java iterator. So this is a list of all the methods with examples provided by the iterator and the list iterator interfaces. So whenever we combine the iterator with the Java iterators or the Java iterations, that is used with the methods with the example provided by the iterator and the list iterator interfaces. Now next one is using the Java iterators. How to use the Java iterators. So one is the how to use an iterator. Now that is a general iterator, that means a general looping how to use. Now how to make the looping, or how to use the looping in the Java, that is using the Java iterators. So often you will want to cycle through the elements in a collections. For example, you might want to display each element. So for example, if I want to display each and every element, that is known as a Java iterator. So the easiest ways to do this is to employ an iterator, which is an object that implements either the iterator or the list iterator interface. So same line, this is the same that is used, and the iterator used to same function Everything is same. Now, how to use in the Java? So before you can access a collection through Iterator, you must obtain one. That means you must obtain the methods, you must obtain the criteria for how to use Iterator, how to make the collection through the Iterator. You must obtain one, and each of the collection classes provides an iterator function. So there is an iterator function, this is the iterator function methods that returns an iterator to the start of the collection. Start of the collection means it is given at the top of the collection, that is using the iterators. So there is an iterator function that is available at the starting of the collection and the starting of the phase of the collection. And by using the iterator objects, you can use each and every element, you can access each element in the collection, one element at a time. That means looping is done one by one. First one object, then next object, then next object. So by using the iterator objects, you can access each element in the collection, one element at a time. That means one element is available at a time. Now, next one is, next line says, in general, to use an iterator to cycle through the contents of a collection, these are the steps that is to be followed. So these are the few steps that is followed with the iterator, that is through the contents of a collection. So first one is obtain an iterator to the start of the collection by calling the collections iterator method. So there is a collection or there is an iterator method that is used with the collection by using the collections iterator method. So first of all, obtain the iterator means how to use the iterator. So we are using the iterator methods for the collection purpose, for calling the collection purpose. The next one is set up a loop that makes a call to the has next. That means how to make to the or how to jump to the next part, that is the has next, and have the loop iterates as long as has next returns true. So as long as the has next returns true, this will give the looping, this will give the loop to the next part. And within the loop, obtain each element or each and every element by calling the next function. So first of all, there is a usage of the iterator, then there is a usage of the hash next function, then there is a usage of the calling the next function one by one, one by one, one by one. Now, these are the three methods that is declared by the iterators in the Java programming. One is a Boolean has next. Now, whenever there is a term Boolean comes, that means that returns either the value true, either the value false. This returns a true if there are more elements. Otherwise, it returns next. Why? Because it is searching for the next element. If next element is found, then only the output is true in case of Boolean. Otherwise, the output is false. So if the output is in this, the output is true. Whenever there is a more element to be gathered together, there are more elements to be present in the looping. Then object next, so this returns the next element. What is the next element? That throws no such element exception is there if there is not as next element. Then void remove, so this removes the current elements, and this throws illegal set exception if attempt is made to use remove function that is not preceded by a call to the next function. So whenever there is a next function, whenever there is a remove or the next function, that is followed with the current element, that is a void remove. So this is a method that is declared by the iterators. Now, next one is a method that is declared by the list iterators. Now, there is a difference between the methods in the iterator and the list iterators. So first method that is defined by that is declared by the list iterator is that void add, that inserts the object into the list in front of the element that will be returned by the next call to the next. That means whenever we are using the next function, that means adding the or inserting the elements or object into the list. Then Boolean has next, so this returns a true if there is a next element, otherwise it returns a true, that is the same point. Then Boolean has previous, so this returns a true if there is a previous element that is available, otherwise it returns a false function. So one is a has next, one is a has previous. Now next is the object next, so this returns the next element, and no such element is thrown if there is not a such next element. So one is a void add, that is adding the elements, one is a has next, That returns the true if there's a next element. Then previous element has next means if there's a previous element, so this returns a true. The next one is object next, so this returns the next element. If there is not a next element that is not presented or that is not available with the object next, then int next index, that means whatever the next index value, so this returns the index of the next element. Index means the reference number. So if there are 5 elements, for example, and if I want to search the 4th element, so this returns the 4, numeric 4, not the content of the variable. Why? Because this is indexing, so this returns the index of the next element. And if there is not an next element, so this returns the size of the list, whatever the size that is available in the list. Next one is object previous, so this returns the previous elements, and if there is no such element is thrown. And next one is int previous index, so this returns the index of the previous element. If there is not a previous element, that returns a minus. Then void remove, so this removes the current element from the list. An illegal state exception is thrown if remove is known or if remove is called before the next or previous is invoked. That means if there is a next part, if there is a previous part that is invoked, so this is representing the next element that is invoked over here. Next one is void set object obj. So this assigns the obj to the current element, and this is the element that last returned by the call to the next or the previous function. So there are two types of function, either the next function or the previous function that is defined by the void set object obj. These are the 9 functions, or these are the 9 methods that is declared by the list iterator, and these are the 3 functions that is, or these are the 3 methods that is defined by the iterators. Now, if you see, this is the same function, this is the same function. Now, let's see about the remove. This is also the same function of the boolean has next, same function of the object next, same function of the void remove. That means whatever the functions, whatever the 3 functions that is defined in the iterator, that must be the same, or that is basically the same in the method that is defined in the list iterators. This is an example that demonstrates both the iterator and the list iterators. So it uses the array list object, but the general principle applied to only or any type of collections. And of course, list of iterator is available only to those collections that implements the list interface. So whenever we are implementing the list interface, so there is a list iterator that is available to the collection. So there is an import java.util.star, that means there is a file that is java.util. Then public class iterator demo. So there is a class, that name of the class is the iterator demo. Then there is a main function, public static void main string args. So there is a main function that is defined over here. The same line in the Java program, public static void main string args. Now next is creating a new list. How to create a new list? We are defining the array list A1 equals to new array list. So we are using the function array list function, and we are using the new keyword for maintaining the array list, and that is stored in the A1. This is the initial phase for creating a new array list, not inserting the element. Only the structure is defined, only the structure is available. We can say the architecture is available for the array list that is stored in the A1. Now, adding the element to the array list one by one. One is the A1.add, then C, A1.add capital A, A1.add E, A1.add B, then D. That means C, A, E, B, D. These 5 elements are stored, and at last there is a F. So there are 6 elements, C, A, E, B, D, F. Now, use the iterators function, or we can say the list iterator function, to display the contents of the A1. So for printing purpose, we use system.out.print. Why it is print? Because it is showing the string, it is using the string, so there is a no, there is only the print. So system.out.print. Then in the next line, iterator itr. So there is the iterator function, there is the iterator object, that is itr equals to a1.iterator. Then while itr has or dot has, while itr has that is defined in the iterator. So there is an object element equals to itr.next. Then system.out.print element plus this one. Then system.out.println for printing purpose. So this is the iterator to display the contents of the A1. Next is modifying the object that is being iterated. How to modify? Same using the looping. In this case, it is using the while loop. So while LITR, that means the list iterator is going to the next function, that is has next function. So automatically it will move to the next part by using the plus operation. So this is the output of this one. One is the original content. This is CAEDF that we are giving to the content of the A1. Next one is modified element of the A1, C plus, A plus, E plus, B plus, G plus, and F plus. That means every element is added with the plus sign. Then modified list backwards. Backwards means starting from the right hand side, that is the last element. Last element is F, so this is F plus, then D plus, then B plus, then E plus, and A plus, and C plus. So these are the modified versions of this one. This is the original case, this is the modified case, and this is the modified list backwards. So these are the iterators and the list iterators that is available in this one. Next one is how to use a comparator. That means how to use the comparisons in the Java programming. So just wait for 2 minutes. So the last phase is how to use a comparator, how to use a Java comparisons in this one. So both the tree set and the tree map also store the element in the sorted order. So we have studied about the functions, how to store in the sorted order, that may be alphabetically, then maybe in the number format, how to store in the sorted manner. However, it is a comparator. They define precisely what sorted order means. That means what is the meaning of the sorted order, how to define the sorted order. That is means how to sort the contents. So this interface lets you sort a given collection any number of the different ways. There are n number of ways by which we can sort the manner, or by which we can sort the content. We can sort the array element that is defined in the sorted manner. And this interface can also be used to sort any instance of the class. Any instance means any method, any criteria that is used with the classes. But the main limitation is that we can sort the content. We are able to sort the content. We are not able to modify the contents. So first one is the using Java comparator. So this is the list of the method that with examples how to provide with the comparator interface, how to define with the comparator interface. This is how to use a comparison, how to compare the content. Now next is how to use a Java comparator. So both these functions are used in a Java comparator, tree set and the tree map, that is used to define the sorted list. There is also the two method that is defined in the comparator interface, that is the collection interface. First one is the compare methods. Next one is the equal methods. Compares the content, or compares two content slightly or equally. So this method shown has two elements for the order. What are the two objects? What are the two arguments that is defined in the compare function? So first is int compare object obj1 and the object obj2. So compare is the name of the function. Int is a data type, that is the return type, and this object of obj1 means first element. Object obj2 means the second element. That means what is the second element? That is the second argument. So these are the objects to be compared, and this method returns the 0 if the objects are final, or objects are equal. And it returns a true if the obj1 is greater than the obj2, and returns a false if the obj1 or obj2 is greater than the obj1. So first variable is higher than the second one, that gives a positive, and the second variable is higher than the first, then that gives a negative, and 0 when both are equal. Next method is equal. This is of the return type boolean. That means this gives the output in true or the false. So boolean equals obj or objects obj. So obj is the object to be tested for equality, and this method returns a true if obj and the invoking objects are both comparator objects and use the same order. So if the same order that is compared with this one, so that uses with the same order for the same equality. Otherwise, it returns false. And overriding equals is unnecessary, so use the comparators should not to do so. This is a program that that shows how to use the compare and the equal methods. So first one is there is a class that is a dog that implements a comparator dog and the dog, and this is the string name. Then private int age. So there is a private int age means a function or a variable that is defined of the private type of the int category. Private int age. Then and there is a dog function that contain two arguments that contain two functions. One is a string n, one is a int a. The name equals to n and age equals to 8. That means n is stored in the name and a is stored in the age variable. Now for return. Now for returning purpose, we use the return name, that is we use the get dog name and get dog age. So one is a variable or one is a function that is defined for the dog name. One is a function that is defined for the dog age. And this is a function that shows how to override the compare to method. So the compare to method that overrides the name of the dog. This is a method how to sort the age, how to sort means how to arrange the age in ascending or the descending. And this is the output of the result. Next one is the summary of this one. So Java collections or Java collection from framework gives the programmer a Java for access to the pre-packaged Java structures as well as to the algorithms for manipulating them. So how to manipulate them, how to make the Java accessible with the data structure that is used to manipulate the content that is defined in the Java. So what is a collection? That is an object that can hold the reference to the other object. That when we refer the other objects, when we use the multiple objects, that is known as the collection. And the classes and the interfaces of the collection framework are used in the Java development. So we are finished with the chapter number 28, that is the Java collections. Next chapter, that is chapter number 29, Java generics. This chapter I'm going to discuss in the next class. I'm going to teach you in the next class, that is in the tomorrow's class. So that's all for today's session, that is chapter number 28. This is one of the important chapters, Java collections, and related with the Java methods. So if there is any doubts, anyone, you can ask the doubts from me. So anyone have a doubt regarding assignment, regarding any module, anything, you can ask the doubts without any hesitation. So please ask the doubts. So this chapter number 28 is clear to each and everyone.